Okay, so now we're going to solve for x given the triangle, which appears to be right-angled, and it has a 50-degree angle, a side length of x, and a side length of 20. So in order to solve this using trigonometric trig ratios, we're going to follow these 6 key critical steps. So the first step is to label the angle and sides. So in this case, I have angle 50. That's my referent angle. So with respect to angle 50, if I go across directly opposite, I get x. So x is my opposite side length. If I go directly opposite from 90 degrees, I get 20. So 20 must be my hypotenuse. Now, given the fact that I have opposite and a hypotenuse, I'm working with sine trig ratio. So I'm going to record that as the sine of theta is equal to opposite divided by the hypotenuse. Okay? So now I can take my next step, which is to substitute the values into that trig ratio formula. So let's work with sine of 50 degrees is equal to x divided by 20. Now the next step I'm going to do is to convert the sine angle to 4 significant digits after the decimal place. So you may wonder, well, how do I do that? And I said, well, I've got my calculator here, and I'll clear it. And so we want the sine of 50 degrees. So I got to look for my sine button. It's right here, sine, and I press 50, and I press equals, and I get decimal 76604. So I'm going to keep those 4 significant digits, decimal 7660. Okay? So let's record the sine of 50 over 1, and I'll show you why we do that. We record decimal 7660 divided by 1 is equal to x divided by 20. Okay? Now it's easy to cross multiply, isn't it? We just cross multiply, so x times 1 is x, and 20 times 0.766 is going to be determined by our calculator. So I take my calculator and I'm going to multiply that by 20. And you should get 15.32. Pardon the glare, 15.32 as our answer. Very good.